100, it gets rid of milliliters. So I'm left with molarity, right? Now, in the other class, there's a couple of you who didn't know how to solve this. Does everybody know how to do the math to get this? If you don't, it's okay. Tell me and I'll help you. You good? We're all good? Okay. I believe you. I could help you. All right. Should we do one more dilution problem?
Is that 12.0 mole?
Molar, capital M, molar.
So that's the same thing as, what was it, moles over liters?
Moles over liters, that's right. That's what the capital M means, is moles over liters.
So the 0.60 is like
0.60 molar is my final concentration. If I took 5 milliliters of 12 molar hydrochloric acid and diluted it to 100 milliliters, the concentration in the final solution would be 0.60 molar. That's what it's asking. Okay? Ready?
You divide it by 1,000 by 2.
12 times 5 is 60, divided by 100 gives me 0.60. 2 sig figs because this one only has 2 sig figs. And we love sig figs, so we gotta know how many are there, right? All right, one more. I can do most dilution problems in my head, because I used to do them all the time. We ready? Okay. So, we have, doesn't really matter which side you write them on either. As long as I know that these two go together and this goes with some unknown, right? Right? Doesn't matter which side they're on. Because the 5 goes with how many milliliters of the 5% do I need to use to make 100 milliliters of 1%? The 100 milliliters goes with the lower concentration. So, you need to take 20 milliliters of 5% and dilute it to 100 milliliters, and that would give you 1% solution. Right? So you ready for me to walk in the office and ask you a dilution question?
Yes.
I'll come over here and see you working, I'll ask you a question. No? Why not? Would you be afraid if I did?
No.
You can do it now, right? Hygienists probably don't do this very much.
Dr. T made us like do the injections.
Yeah, the assistants would do this more probably than the hygienist would. Because the hygienist is going to be cleaning teeth most of the time, but the dental assistant needs to know how to dilute medications and stuff for injections and stuff, right? Okay? Any questions on dilutions?
I just have a question on this. I'm not seeing how you decided what side the 1,000 and the 10 go together.
1,000.
I mean, the 100 milliliters.
Like I said, it doesn't matter if I put this on that side or on the other side. These two just have to be together, don't they?
Well, that's what I'm not seeing. I don't know how you decide what figures need to be.
Together? It says to produce 100 milliliters. So that's my final volume. And 1 is less than 5. I'm going to dilute it to make a lower concentration.
Okay.
So, and this is my final volume. Okay? Concentration can't go up. So I could have written it, it doesn't matter what side they show up on. Okay? I could have written it the same way as 5.0% times V equals 1.0% times 100 milliliters. Still get V equals 20 milliliters. Same thing. The key is to figure out which two together like this, right? Of course, the concentrations are going to be on opposite sides, but where does the volume go? The volume in this case told me my final volume was 100 milliliters. So I would take 20 milliliters of the 5% solution, put it in a flask, and then add another 80 milliliters of solvent to dilute it. Okay? That's exactly how you do this. Does that make sense? A little bit? There's several dilution problems in the homework, like 4 or 5, because I think it's important. Yes, Miss Megan, you got a question?
Because I'm a visual learner,
Yes, ma'am.
just to help you out a little bit. When I write the C1, V1, C2, I write it down long ways so I can see it. And
So you
then-
can see each one.
Yeah, I see each one, and then I know where to put which one it is, and whichever one is blank, that's going to find it.
Yeah, C1, V1 equals C2, V2. Right?
But I write it down long ways.
What, you write out concentration
Yeah,
times
like
volume?
C1, V1, C2.
Well, that's what I just wrote right here.
It's
Like,
not already
like,
vertical.
like,
She means
straight,
vertical, not
straight,
vertical.
straight.
Vertical.
Yeah.
Oh,
Sorry. So I can see it,
yeah.
and then whichever one's left.
So you just do like a little chart.
Mhm.
Yeah. That works.
I don't know if that helped you out or not. For anybody.
Yeah, you could do a chart. I mean, you could do like concentration and volume, right? 1 and 2. My concentration 1 is 5.0. Concentration 2 is 1.0. You could do it a lot of different ways. So you need to know that you're solving for your initial volume. And C times V must be equal to C times V. There's a bunch of different ways you can try to do it. Okay? All right. So, the last section of the chapter deals with solutions, and it just goes into some definitions and stuff. I'm not going to talk about it. There's no calculations in it. It's about reading and understanding what the definitions are. I do want to point out 2 issues here, and that's the definitions of osmosis versus dialysis. Okay? Osmosis involves the movement of solvent across a membrane. Only solvent. Dialysis involves the movement of solvent and solute. In most cases, you're moving a lot of solute. You try, like when you hear about kidney dialysis, you try to match the solvents, and in the solvent, the solute will move from high concentration to low. In osmosis, it's the opposite. The solvent moves from low to high. Okay? So when you read that section, there's like 1 or 2 problems in the book or in the homework talks about, is this solution, what would this cause? Would it cause crenation or hemolysis for red blood cells? Or is it isotonic? Understand some of the definitions in there. I'm not going to go over it, it's just reading, okay? Y'all can handle that. I know you can. Do that all the time in biology class. We all know biology.